Hi everyone, today we're going to look at how we can represent expressions using algebra tiles. We'll begin by looking at what algebra tiles actually are and how each one of them gets their name. We'll start with this algebra tile, which is the 1 tile. It gets its name because it has an area of 1. It has a width of 1 and it has a length of 1. So when we multiply 1 by 1, we get an area of 1. This is the 1 tile. The second tile is the x tile. This tile has a name of x. It gets its name because it has a width of 1 but an x as its length. So 1 times x, or its area, would be x. The third tile is the x squared tile. It also gets its name from its area. It has an x for a length and an x for a width. So when we multiply x by x, we get x squared. Finally, the last tile is our x cubed tile. This tile gets its name from its volume. It has a length of x, a width of x, and a depth of x as well. So it is known as the x cubed tile.
Now that we know the name of each of the tiles, we can use them to represent expressions. The expression 3x plus 2 could be represented by 3 of these x tiles and 2 of the number tiles. This representation would show us 3x plus 2. The 3x is represented here by 3 of the rectangles, and the 2 is represented here by 2 of the little square number tiles. We also know that all of these tiles would be red because each of the items inside, or each of the terms inside of our expression, are positive. There's an imaginary plus sign out front of the 3x. This next expression has 4 terms within it. We'll represent the negative x cubed by using one of these tiles. We know that it'll be blue because there is a negative out front of the term. We know that it's 1 because there's an imaginary coefficient of 1 in front of any variable that doesn't have another number listed. And we know that it will be the 3-dimensional tile because it's an x cubed. We'll represent the 2x squared using 2 of these tiles. That tile is the x squared tile, and in this case, we require 2 of them. We know we need 2 because of the coefficient of the variable x squared. We know that they'll be red because it is a positive 2x squared. For the third term, we will need to use the x tile. We'll need to use a blue x tile because the term is negative. So we will have 1x, 2x, 3x, 4x, and 5x. Again, we have 5 of them because the coefficient is a 5. They're blue because the coefficient is negative, and they are rectangles because we're dealing with an x tile. For our final term of our expression, we will need 4 of our number tiles. We know that they'll be red because it is a positive term. We know that we'll need 4 of them because that was the constant that was provided at the end of our expression. So here we have our expression of negative 1x cubed plus 2x squared minus 5x plus 4. This expression will require us to have 6 of our x squared tiles. They will need to be blue because it is negative. So we have negative 6x squared. For our 4x, we will need to use the rectangle tiles. They'll need to be red because it's a positive term. And we'll need 4 of them because there is a 4 as a coefficient of the x. Finally, we'll need negative 2, which will be represented by our number tiles, and they'll be blue because it is negative. We can also think in reverse in terms of our expressions and representing with algebra tiles. By being given a diagram, we can create the related expression. In this case, we begin with some x squared tiles. They're positive, and we have 2 of them. So this term will be represented by positive 2x squared. We have x tiles because they're rectangles. There are 8 of them, and they are blue, so we will require a negative sign. And finally, we will have 1 as our constant at the end of our expression. For this expression, we will begin with some x cubed tiles. There are 2 of them, and they are positive. We will then move on to needing an x squared term. We know that it will be negative because it is blue. We can place a 1 here if we would like because there is only 1 of them, or we could leave that 1 out because it is not necessary to include a coefficient of 1. We know automatically when there's a variable without a coefficient that it is a 1. We'll need some x tiles for the rectangles. There are 4 of them, and since they are red, we need a positive symbol out front. Finally, we will have positive, they're red tiles, and they're just little number tiles, so we will record an 8 since there are 8 of them. For this expression, we have positive 4, and then we have negative 6x squareds, and then we have negative 3x cubes, and finally we have positive 1 or positive x. When we look at this expression, we would actually want to rearrange it. When we list our expressions, we list them in order of the biggest type of tile or the biggest exponent to the smallest type of tile or the smallest exponent. So as we rearrange this expression, we would list it as negative 3x cubed minus 6x squared plus x plus 4. And we'll just put an equal sign out front to show that each of those expressions are equivalent. In our last example, we'll have a little preview of what we're going to do in our next lesson when we begin collecting like terms. At first glance, this expression looks like it would be positive 4x squared plus 2x plus 4x. At this point, we might recognize that those x tiles could actually have been placed together. We could actually relocate them so that all of those x's, because they're all the same, are right beside each other. If we were to do that, we would be left with positive 4x squared plus 6x. And what we've done there is we've combined these terms together. That's all for now in terms of representing with algebra tiles. See you in the next lesson.